Let's say we have three identical uniform rods that are each attached by two or more forces, all perpendicular to the rods, and are all equal magnitudes. Which of the rods should be in static equilibrium if an additional force is applied at the center of mass of the rod? Okay, so what does it mean to be in static equilibrium? Well, static equilibrium means that our net force has to be equal to 0, and our net torque has to be equal to 0. So I'm going to look at these cases and see if any of them work. And really what I want to do is I can look at this and say, hey, what's my axis of rotation? Put it at the center, see if the thing rotates. So in case 1, I see that I have a force pointing up, a force pointing down. These two forces are going to give rise to torques that are going to cause this thing to spin. Both of them are going to cause it to spin in the clockwise manner. So this bar is going to look like it's going to want to spin in the clockwise manner. This third force up here, yeah, if I add another force pointing down, I have two forces up, two forces down. That cancels my force out, but it doesn't stop the rotation. So definitely can't be only one, and it can't be all three, because this one will always rotate, or always start to rotate. It'll always have a net torque not equal to 0. This case is same as the first one. This guy is going to cause this to rotate. This one's going to cause it to rotate, right? It's going to try to rotate. You can think of an axis of rotation in the center. For static or equilibrium cases, I can choose any of my axes, and all of my axes can't, any of the torques about one axis should all add up to 0 for me to be in static equilibrium. So I'm going to pick one, and I'm seeing this is not a case. This thing's going to rotate again. So again, this one, it doesn't matter where I add a third force. There is no third force that I can add in this case to actually get my net torque to not equal 0. This last one, on the other hand, I see, oh, so 2 is out. Oh, and 1's out. So C better be the right answer. So let's check this. This force right here is going to cause this one to rotate in this direction. This force is going to give me a torque that's going to want to rotate in the counterclockwise direction. So these are going to be canceling each other out because they're the same distance away. D1 and D2 are equal because their opposite sides are at the very end of each other. I'm, again, choosing an axis of rotation around that point. D3 does not, or force 3, this one right here, does not provide any torque on this object because it's not rotating, because it's applied at the axis of rotation, so there's no distance. But I have 2 forces up and 1 force down, which means, oh, that's wrong. I need another force pointing down of equal magnitude to those 3, pointing down, to cancel it out. So 1, 2 up, 1, 2 down, that works. Both of these two are attached at the axis of rotation. This torque wants to rotate it to the clockwise. This torque wants to rotate it counterclockwise, so they're going to cancel out. So choice 3 is my correct answer.